everyone, my name is Nikita and I'm from the Bodhi Academy. Today we are going to start a new chapter from 9th standard science textbook, that is chapter Gravitation. Okay, this is like a continued part of the other chapters from physics part of the science subject in 9th standard, that is force and laws of motion and motion. We have already seen what is motion. Okay, we have studied what gets a object into motion and what are the different laws of motion. Okay, which are the different laws of forces. Okay, today we are going to see, in this chapter we are going to see the next concept. Okay, the gravitation and gravitational force and different concept related to gravitation. Okay, when we talk about gravitation, we all know that there is a famous story about Newton. Okay, that when Newton was sitting under a tree, apple fell on him. Okay, and that made him think that what attracts this apple towards the earth. Okay, so this brings us to a concept wherein we think that when thrown upwards, it reaches a certain height and then it falls downwards. Okay, um, an object which is thrown upwards, it goes to a certain height. Okay, upwards it goes to a certain height and then it falls downwards. So why is it so? Why does it come downwards? So Newton was sitting under a tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Okay, so he saw that earth is attracting the objects which are going up. Okay, any objects which is thrown upwards at a particular height, okay, it is coming down towards the earth. Okay, however high it goes, okay, however high the object can go, it has to come back towards the earth. So what is it that is attracting it towards the earth, and does it apply to all the objects, and does it apply to all even to the moon which revolves around the earth? So these questions had come into the mind of Newton. Okay, he conjectured that the same type of force is responsible in both the cases, in case of apple coming down towards the earth and also in case of moon attracting towards the earth. He argued that at each point of its orbit, the moon falls towards the earth. So he stated that this is the earth. Okay, then this is the moon. Okay, this is its orbit at which it moves around the earth. Okay, he stated that at each particular location it moves in the particular orbit. Okay, at each location when it moves in the particular orbit, it experiences a force towards the earth. Okay, it experiences a force towards the earth. Okay, it is attracted towards the earth. Now what was this force? This force was the gravitational force. Okay, now over here we can see that there is a boy holding a string. Okay, in the string at the end is a stone which is tied. Okay, and it is moving in a circular motion. Now before the thread is released, the stone moves in a circular path with a certain speed and changes direction at every point. So when the boy is holding the string and moving in a circular path, the stone is moving also in a circular path, right? And it is changing its direction at each particular point. It is changing its direction and it is in a circular path. Okay, it has a particular speed. Once it is released, it will move in a particular direction. In whatever direction it was released, it will move out of it. Okay, so the change in direction involves a change in velocity or acceleration. Okay, so over here we can see that if the direction is also changing, there will be change in velocity and acceleration will be produced. The force that causes this acceleration and keeps the body moving along a circular path is acting towards the center This force is called as centripetal force. Okay, the force that causes the acceleration and keeps the body moving in a circular path, it acting towards the center, this is called as the centripetal force. Okay, so when a particular force keeps a body moving in a circular direction, a circular path, by changing its direction and changing the acceleration, then it is said to be in the force that is causing this to happen is said to be the centripetal force. Okay, so we know that the centripetal force of this concept is same as the centripetal force of revolving of the moon around the earth. Now, according to the third law of motion, the apple does attract the earth. Okay, we know that in the third law of motion, in the previous chapter we have studied that each object has a equal and opposite reaction, right? Means if one object exerts a force on the other object, the next object will also exert equal force on the previous object. This means that each one will have the apple and the earth, for example, each one will have a force on each other. Okay, but according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. In the second law of motion, we have seen that acceleration produced for larger objects is less, and acceleration produced for smaller objects is more. So the mass of an apple is very small as compared to the earth. So we do not see earth moving towards the apple, we only see the apple moving towards the earth. Okay, for example, okay, apple moving towards the earth. Okay, both are experiencing the same force according to third law of motion, but this is small mass and this is greater mass, right? So we see both are exerting a force, but Newton's question was, why is it that apple only move towards the earth and earth is not moving towards the apple? This is because the mass of apple is smaller. Okay, so it will produce a larger acceleration and mass of the earth is large. Okay, so it will produce small acceleration. Larger acceleration will make the apple move towards the earth. So we only see movement in this direction and we do not see the earth moving towards the apple. Okay, so this is the answer to the question. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and the planets. Not only the earth attracts an apple and the moon, but all the objects in the universe attract each other. And this force of attraction is called as gravitational force. Okay? So gravitational force is the force which attracts the objects in universe. Okay, example is moon to earth, then planets to sun, and apple to the earth. So gravitational force is the force of attraction. Okay, so here we saw what is gravitational force. Now we are going to study the universal law of gravitation. Okay, which is the law which talks about gravitational force between two objects. Okay, universal law of gravitation, the statement says that every object in the universe attracts every other object. Okay, so one object, second objects with a force. Okay, this is the force, the gravitational force. This force is proportional to the product of their masses and inversely proportional to the square of distance between them. Okay, so this law has three parts. First part is every object in the universe attracts every other objects with a force. Okay, this is the first part. Second part is this force is proportional to the square of the mass, proportional to the product of the masses. Okay, product of the masses, directly proportional. Okay, and third part is it is inversely proportional to the square of distance between the objects. Okay, so let us see how we get this law. Okay, so now okay, so there are two objects, one of bigger mass and one of smaller mass. So for here mass will be capital M, for here it will be small m. Okay, now the distance between the two is small d. Okay, now let's go one by one. Okay, the force of attraction exists between the two objects. Okay, one object exerts the force on the other object. Okay, so it is this one exerts a force on this and this on this, so they exert a force. Okay, so second part of the statement says that the force is directly proportional to the product of the masses. Product of the masses means which are the two masses over here? Mass is m and m. Okay, so product of the masses means force is directly proportional to the product of the masses, m multiplied by m. Okay, second part says that it is inversely proportional to the square of distance between them. We know that distance is d, so square of distance will be f is inversely proportional to the square of distance. So combining these two statements, we get force is directly proportional to upon d. Okay, when we have to remove the proportionality sign, we have to put a constant is equals to sign and a constant. Over here the constant is g. Okay, so the constant over here is g. Now we find from here, we will find the constant of proportionality. What will be the constant of proportionality? If I have to find the constant of proportionality, then g is equals to f d m into m. Okay, so over here we'll see that this is how we find the constant of proportionality. Now the SI unit of g can be obtained by substituting the units of force distance. Now I want to find the SI unit of g. So how will I find? We know that SI unit of force is Newton, d is meter square. Okay, and kg, so kg square. So this can be written as Newton meter square kg inverse. Okay, the value of g was found out by Henry Cavendish by using a sensitive balance. The accepted value is 6.673 into 10 raised to minus 11 Newton meter square kg inverse 2. Okay, so this is the accepted value of g, gravitational constant. G is called as the gravitational constant. So this is the universal law of gravitation. So over here there is some importance of the universal law of gravitation. Okay, what is that? We can find out that the force of gravitation is the force that binds us to the earth. Okay, which binds us, first of all, us to the earth. Second is motion of the moon around the earth. Okay, the motion of the moon around the earth, and the motion of the planets around the sun, and the tides due to the moon and the sun. Okay, the tides. which are caused at the sea, they are also because of the gravitational force. So this importance of universal law of gravitation is important. So the question over here will be explain and derive the explain the universal law of gravitation and derive the gravitational constant and give the importance of universal law of gravitation. Okay, so today we saw what is the first of all, what is the force of gravitation, what is gravitation, what is the force, gravitational force, and thirdly we saw the universal law of gravitation. So this is it for the video. In the next video we will be studying more concepts on gravitation, and we will be looking into other forces and other concepts which relate gravitation and other things. Okay, so yes, thank you for watching my video. Please like, share and subscribe to our channel.